When archaeologists cleared the ash and rubble after the 2019 fire at Notre Dame, they found 12th century iron staples embedded directly into the stone masonry, not added later as decoration, but integrated into the building fabric itself during the very first phase of construction. Who designed this system? How did medieval builders place structural metal so deeply into the cathedral? And does this discovery change only one building's history, or the entire model of what that century could actually do? The accepted story treats the 1100s as far less advanced in precision metal integration than these findings would imply. The force of the claim lies in placement rather than mere existence. The fire did not reveal hidden chambers or lost symbolism. It revealed a practical building method that looks out of place in its own century. Carbon dating confirms the iron was forged and installed during the 1160s, which means the oldest standing sections of Notre Dame were never pure stone. They were a hybrid structure from the beginning. If the cathedral had been built the way most historians assumed, with stone stacked on stone and held by gravity and mortar alone, there should be no structural iron buried in the joints. But the iron is there, and it is everywhere. Before the video ends, you will see exactly what the physical evidence eliminates from the standard explanation, what it leaves with no account, and why the question of who and how remains open. Here is one small payoff before we go further. The iron staples are shaped like massive letter U clamps, and they were used to bind stone blocks together into a single cohesive unit. That is not decorative, that is load-bearing engineering. And you can check this yourself by looking at the restoration photographs released by the French Ministry of Culture, where the iron is visible in the masonry cross-sections. Now the question becomes how anyone in the 1200s knew to do that. The default story says medieval masons built cathedrals by stacking carved limestone, using wooden scaffolding, and relying on the compressive strength of stone arches to hold the weight. Metal, if it appeared at all, came later as ornamental hinges, window grills, or exterior brackets. The walls themselves were supposed to be stone through and through. That model works for many Romanesque churches. It even works for early Gothic experiments. But it does not work for Notre Dame, because Notre Dame was not built that way. The iron was not added during a renovation. It was installed in the 1160s during original construction, which means the architects who designed the cathedral planned for metal from the very first blueprint. And that creates a problem. If this technique was known and used at the highest level of 12th century engineering, why does it appear in no surviving manuscript, no architectural drawing, no Masons Guild record, and no other cathedral from the same period? The stones became the only record. Here is the first anchor contradiction. Scientists dated the iron by analyzing microscopic charcoal bits trapped inside the metal during 12th century smelting. This is not guesswork. This is radiocarbon dating of the fuel residue left over when the ore was turned into iron. The charcoal fingerprint places the metal in the exact decade when the cathedral's choir and nave were rising. If the old model were true, and iron played no structural role in Gothic construction, you would expect to find no 12th century iron inside the masonry at all. What you actually find is thousands of staples forming a hidden frame that acted as a structural backbone for the entire building. That mismatch is not a detail, it is a reversal. The cathedral was holding itself together with a system that was supposed not to exist. Now add the next clue. Builders poured molten lead over the staples to protect them from rust and lock them into the stone joints. This is not a quick fix. Pouring lead requires heating it to over 300 degrees Celsius, transporting it up scaffolding while still liquid, and placing it into pre-carved channels without cracking the limestone. That level of coordination suggests the iron and lead system was not an emergency repair or an experimental addition. It was a planned, repeatable, industrial-scale construction method. If this were a one-time innovation by a single genius mason, you would expect rough execution, irregular shapes, and no uniformity across the building. What you actually see is standardized production. The staples show a uniform size and shape across hundreds of installation points, which means someone was manufacturing them in volume to specification at a central forge. The old model has no explanation for that kind of production control in the 1100s. Here is where the logistics get harder to dismiss. Medieval masons had to hand-chisel exact grooves for the iron before each stone was laid in place. This is not like adding a bracket to a finished wall. The grooves had to be cut into raw limestone blocks before they were hoisted into position, which means the blacksmiths and the masons had to work in tight synchronization at the construction site. The blacksmith could not make the staples until the mason knew the exact dimensions of the joint. The mason could not finish carving the stone until the blacksmith delivered the iron, and both had to finish before the block was lifted and mortared into place, because once the stone was set, there was no going back. That requires planning, communication, and site-level coordination that the standard story does not account for. If you believe the 1100s were a period of primitive trial and error building, then this system should not be possible. But it was not only possible, it was executed at a scale that implies institutional knowledge and workforce training. Now consider where the iron was placed. Most staples were found at the top of the walls, over 100 feet up, where wind and pressure are greatest. These are not symbolic touches. These are structural anchor points. The iron was strategically placed only at critical junctions, where vault ribs met the outer walls to handle maximum stress. The staples functioned like architectural glue, preventing stone blocks from sliding under the immense weight of the roof. This is tensile engineering. Stone is strong in compression but weak in tension. It can hold weight pushing down, but it cannot resist forces that pull or twist. Iron can. By embedding iron into the joints, the builders gave the stone a hidden, tensile strength that allowed for thinner, taller walls. Without the iron, the walls would have needed to be thicker and heavier to resist the outward thrust of the vaults. With the iron, the cathedral could rise higher and let in more light. That is not decoration, that is structural logic. And it is logic that should not exist in the 1200s according to the timeline we were taught. Here is the next problem. The 2019 fire reached 800 degrees Celsius, hot enough to melt the lead roof and burn through oak beams that had stood for centuries. But the iron staples remained structurally intact. When restoration teams sifted through the rubble, they found the metal still locked in place, still holding stone to stone, still doing the job it was designed to do 850 years earlier. If the iron had been weak, corroded, or poorly installed, the fire would have exposed that. Instead, it exposed durability. The staples were not just surviving, they were performing. That suggests the builders understood material science well enough to choose the right grade of iron, the right sealant, and the right installation depth to ensure the system would last. They even left small gaps for the metal to expand and contract without cracking the surrounding limestone. That is thermal engineering. It is the kind of detail that comes from experience, testing, and transmitted knowledge. But if that knowledge existed, where is the written record? Here is what makes the trace problem worse. Chemical analysis of the ore connects the staples to specific 12th century mines and forges across France. The trace mineral fingerprints in the iron match known sources in Burgundy, Champagne, and the Paris basin. That means the project required a supply chain. Someone had to locate the ore, smelt it into workable iron, transport it to the construction site, and deliver it on schedule as the walls rose. That is not local improvisation. That is logistics. It is procurement, quality control, and multi-site coordination. If this system were a secret technique known only to the Notre Dame team, you would expect to see no supply chain, no standardization, and no evidence of repeat orders. What you actually see is industrial investment on a scale that implies the method was not experimental. It was operational. Now step back and look at what this changes. The discovery makes Notre Dame the earliest known example of a cathedral built with an integrated iron armature. It is not the earliest use of iron in construction. Romans used iron clamps, but it is the earliest example of iron used as a continuous structural system inside a Gothic cathedral. That distinction matters because it means the technique was not inherited from Rome. It was either reinvented in the 1100s or transmitted through a channel that left no written trace. Either option breaks the old model. If it was reinvented, then 12th century engineers were far more capable than the standard story allows. If it was transmitted, then there was a knowledge network operating across Europe that we have no record of. Both possibilities point in the same direction. The past was more technically sophisticated than we assumed, and the gap between what was built and what was written down is wider than it should be. Here is the final clue that makes the question unavoidable. Because the iron was buried deep in the masonry joints, it remained invisible to the world for 850 years. Architects who studied Notre Dame in the 1700s saw stone. Engineers who analyzed it in the 1800s saw stone. Historians who wrote about it in the 1900s saw stone. None of them knew the iron was there, because the iron was never meant to be seen. It was hidden in plain sight, doing its job in silence, holding the cathedral together, while the visible elements took all the credit. Without the 2019 fire, this level of forensic access to the inner masonry would have been impossible. The destruction became an accidental excavation. The ash became a forensic opening, and what it opened was not a mystery of faith or symbolism, but a mystery of capability. The question is no longer whether medieval builders used iron. The question is, who taught them to use it this way, how they coordinated the work, and why the method disappeared from every written record while surviving in the stone itself. So here is the answer to the question promised at the start. Who put iron inside Notre Dame 850 years before anyone expected it? The physical evidence eliminates the idea that this was a later addition, a repair or an accident. Carbon dating, charcoal analysis, and ore fingerprinting all confirm the iron was integrated during original construction in the 1160s. The scale eliminates the idea that it was improvisation. Thousands of staples, uniform in size, placed at calculated stress points, sealed with lead, and supported by a multi-region supply chain, all point to a planned system. But the evidence cannot tell us who designed it, because no name appears in any surviving document. It cannot tell us how the knowledge was transmitted, because no manuscript describes the method. And it cannot tell us why the technique vanished from the written record while continuing to function inside the building. What this changes is simple. Notre Dame was not a stone cathedral with decorative metalwork. It was a hybrid structure from the beginning, engineered with precision-integrated iron that allowed it to rise higher, stand longer, and survive stresses that pure stone could not handle. The 1100s were not primitive, they were capable. And the gap between what was built and what was written is now undeniable. The stones remember what the records forgot. And that should make us ask what else we have been taught to overlook.